I was just going to work through the study guide with you guys, if that's okay. Hopefully we'll get through everything, but please, if I'm doing a problem and you're confused, tell me. You might have to yell or have Mrs. Jetty yell for you and tell me to stop and go back over something. The first thing on your review, we had this table, and I was asking you all kinds of questions about the domains and ranges. On this, it asks you to do a sketch to support your answer. If I were to put these questions on your test, you would get a point for your sketch and then a point for correctly telling me the domain or range. Now, when I just say sketch, I am not looking for anything too fancy. I'm not even asking you to necessarily do a parent function, although you certainly can. I'm not specifying that you have to have a minimum of 3 exact points. This is just a rough sketch for me to see what you were looking at when you decided the domain and range. So on the first one, if you're looking at the square root of x plus 4, that plus 4, it's under the square root, so it's attached to the x. Anything attached to the x does the opposite of what you think. So when you add to your x, you're actually moving to the left 4. And so if you think about your regular square root graph, it's just that little arch. So if you move that left 4, it looks like this. That's all I'm asking for on your sketch, although you can certainly give me more detail. Now, the nice thing about these, you guys have Desmos or a graphing calculator. You have your graphing calculator on the Chromebook. So if you're confused about which direction the graph goes, or maybe you can't remember what the square root graph looks like for sure, use that graphing calculator and double check yourself. Don't miss points on something that you can easily use your resources to find. Okay, so when I say the domain is talking about your possible x values. And so if I'm looking at x, I'm going from left to right. So if I'm moving from left to right, the first x value I hit is -4, and then it keeps going forever in the positive direction. So it starts at -4 and goes to infinity. So the correct answer for that one would be H. Number 2, if I have a square root graph and I put a plus 4 on the outside, what does that plus 4 do? Moves it up. It's on the outside, so it's y. So I'm taking that same basic shape and I just shifted it up 4. Okay, this time I'm asking you for the range. Range is your y, so it goes, we want small to large. So if I'm moving along the y-axis, the first value we hit is 4, and then it keeps going up. So it's 4 to infinity. So the correct answer there is B. C, x squared. What does x squared look like? A parabola. And what would that -16 do? Moves it down because it's on the outside. So your normal parabola shifted down 16. Just a rough sketch. And of course, you can use your calculator if you need to confirm anything. When I ask you for the domain, that's talking about your x. So as you go from left to right. This parabola, as it extends, it keeps getting wider and wider. So it's going in both directions. So it's going to eventually hit all the negatives and all the positives. So that means the correct answer is A, negative infinity to positive infinity. D, we again have an x squared, so it's again a parabola. What's that -1 going to do to your graph?
Talk louder.
Down 1.
Down 1, thank you. So this time I asked you for the range. So starting on the y, the lowest value is -1, and it goes up forever. So it would be -1 to infinity, which is G. Okay. Next one we have is the cube root. What does a cube root graph look like? sideways chair. And if you didn't remember that, how would you figure it out? You're not looking at the wall. You can turn your desk the other direction. I know what your answer is. You guys have a graphic calculator. You know, there's nothing on the wall that you don't have in your hand with the calculator anyway. So, this is your sideways chair, and the -2, it's on the inside, so it's attached to the X, and it does the opposite if it's attached to the X. So it's actually going to move it 2 in the positive direction. So you are moving to the right 2. I asked for the domain this time. That's your X. But if I move along my X-axis, I'm hitting all the negatives and all the positives. So it is, again, negative infinity to positive infinity, A. F, it's that cube root again, so sideways chair. This time the +2 is not under the cube root, so it's moving it up 2. And I asked you for the range. Range is talking about my y's. If I move along the y-axis, though, this piece is going down, this one's going up, so we eventually hit everything. So it's, again, negative infinity to positive infinity. G, what's the absolute value look like?
A V.
A V. What's that +3 going to do? Left 3. Yeah, we get to listen to a fussing baby. So we take our absolute value and move it left 3. I'm asking you for the domain. That's your X. But again, as this thing goes, it's going to eventually hit all the negatives and all the positives because it's getting wider and wider. So that is A, negative infinity to positive infinity. H, we have our absolute value again. The -3 is on the outside. So that moves the whole thing down 3. So then if we are looking at that, looking at our y's, our lowest is -3, and then it goes up forever. So it would be -3 to infinity, F. Okay, I, we have our parabola again. The -3 would take it down 3. The domain, it's a quadratic, so it keeps spreading out as we go for each direction. So it is A, negative infinity to positive infinity. And J is again a parabola. What does that 2 do?
Makes it skinnier.
Yeah, it's like a vertical stretch. It's just making a skinnier parabola. But if I'm talking about my range, those are my y values. So my lowest y value is still 0, and then it goes up forever. So 0 to infinity, D. Okay. Any questions about how I did those or what I would expect on those types of questions?
No.
Anybody?
No.
All right. Moving on then. So the next question, I'm asking you to describe the transformations. Okay? So worst case scenario, if you're taking your test and let's say you can't remember if that +4 would move it to the left or to the right, how could you figure it out other than just guessing? Graph it. You have a graphing calculator at your disposal. So go ahead and graph it if you're not sure. First thing I notice when I look at this is there's a negative on the outside. So what's that negative going to do?
Flips over x-axis.
Yep. So we flip over the x. Okay, the +4, it's on the inside. Inside changes x and it does the opposite. So if I add to x, it would actually move it in the negative direction. So it would go left 4. And what's the +2 on the end do? Up 2. So that's all I'm asking on this question. Just tell me in words what's happening. All right. Number 3. I'm asking you about the symmetry. There are 2 ways to tell the symmetry. Do you guys remember what those are?
change the sign of, it depends on what you're looking for.
Right. You can plug in a negative for the opposite variable. So in other words, the algebraic way, if I'm asking you to check the x-axis, what you're going to do is change your y to a negative y. Okay. If I do that, is there any way to turn that back into the original equation? No, so it is not symmetric to the x. To check symmetry to the y, you make the opposite variable negative. So we make our x negative. Okay. If I square a negative, what happens to that? It makes it positive. So when I do this, now it's the same as the original equation, which means, yes, it is symmetric to the y. To check the origin, you make both variables negative. Now with the x, just like we saw on part B, when you square that negative x, it does become positive, but that negative y doesn't go away. So this doesn't change back into the original, so it is a no. Okay, that's one way of doing it. I'm going to ask on test, I would say you have to support your answer using something. So this is the algebraic way. What's the other way we can check? You could look at the graph. If you graph that on your calculator, or by making a t-chart, or by using transformations, we just have a parabola. It's skinny and shifted up. Okay, so it would look, you're looking at a calculator, you see something like this, except a little prettier because I'm not good at graphing. And I can see, symmetric to the x-axis means if I fold my paper on the x-axis, it overlaps itself. And that is definitely not the case. If I fold my paper on the y-axis, would it overlap itself? If I fold my paper over this way, do those two halves overlap?
Yes.
Yeah. Origin says you have to fold both. If I fold it over the y, it overlaps, but then if I fold it over the x, it would go down here. So that wouldn't work. So on the test, you either have to show me that you're plugging in the negative, or you have to draw a graph and answer it from the graph. All right. Any questions there? Okay. Let's go down to the graphs then. So if appropriate, draw a parent function. Basically, I would expect a parent function on most all of these, except like your piecewise functions. You can't really do a parent function on those. The greatest integer function, number 5, I'm just going to be upfront with you and tell you right now I'm probably not going to put a greatest integer function on the test. Obviously, I haven't been there with you guys, and that's one of the hardest pieces. So I'm going to tell you right now you're not going to have one like number 5 on the test. So I'm not going to even worry about that one a whole lot. So you would be expected to draw a parent function on 4, 7, and 9 here. So on these, I am looking for exact points, a minimum of 3 on both the parent function and the final graph. Number 4, what's our parent function?
Just a V.
Yep. So exact points, it's just like making a t-chart. Absolute value of 0 is 0, absolute value of 1 is 1, 2, 2, negative 1, 1, negative 2, 2. So do make sure that you have at least 3 of those clearly marked. I want your parent function to be dashed. Some people like to color code things. I know sometimes I have people that like to highlight their final graph or something. That's fine if you want to do that. Now let's talk about our transformations. This plus 3, I wrote it kind of weird. I put it in the front, but that's no different than having a plus 3 on the end. So what's the plus 3 going to do? up 3. And that plus 1 would move it left 1. Okay, so then you take each of your 3 points that you moved, that you marked originally, and go left 1 and up 3 with those. Obviously, the graphing calculator, it's not going to give you those exact points, but you can definitely use that to check yourself at the end. Look at the graph on your calculator and make sure it matches up. Just a couple tidbits. How do you tell by looking at a graph if it's a function? Okay, so if I gave you a picture and asked if it was a function, this one would be yes, it passes vertical line test. If I asked you about increasing, decreasing, constant, if for this particular graph, as you go from left to right, this first section of the graph is falling, so that would be?
Negative infinity to -1.
Right, it's decreasing from negative infinity to -1. Or sorry, not negative, yeah, -1. And then starting at -1, it's going up, so it's increasing from -1 to infinity. Remember, if you're writing those intervals, you list the x values. The only time you use y values in an interval is if you're setting up the range. Otherwise, we always go with the x. All right, those are just kind of a side note, but some other things that I might ask you. Number 5, if you guys are okay with it, I would like to come back to that if we have time at the end. Since I've already told you I'm probably not going to put a grade center on the test, I just want to save that and we'll do it at the end of class if I still have plenty of time. Number 6, how do we graph piecewise functions? Right. You need an XYT chart for each piece. So here we have to have 2 of them. Okay, so if I'm graphing the first piece, no matter what, tells me we use this piece if x is less than 0. I have to start by plugging in a 0. But because that wasn't an equal to, will it be an open or a closed circle? It'll be an open. So I'm going to start with 0. It will be open. And then x has to be less than 0. So then you put things smaller than 0. So maybe -1, -2. All right, if we put in 0, opposite of 0 is, put in -1, opposite of -1, and opposite of -2 is 2. So we plot those. 0, 0 is an open circle. -1, 1, -2, 2. So we have to extend this graph. We start at 0, 0, and then we had these other points, so it extends that direction. Now we graph the second piece. So it again has to start at 0, but because it has an equal to, that would be a closed circle this time. And then we want things bigger than that, so we can do a 1 and a 2. So 2 times 0 is 0, 2 times 1 is 2, 2 times 2 is 4. When I go to 0, 0, I already have an open circle, but now I have a closed one. If you have an open and a closed at the same spot, you just make it closed. Then we have 1, 2, and 2, 4. And then extend that line. Make sure when you're done graphing these, they are functions, so it should pass the vertical line test. If I had extended one of these lines the wrong direction, it would fail the vertical line test, and that tells me I need to go back and look at it again. I made a mistake. All right, is that one okay? All right. Let's look at number 7. So parent function here is your square root graph. Okay, when I do parent functions, I'm really just making a t-chart in my head. You know, the square root of 0 is 0, square root of 1 is 1. You want a nice number to plug in, so square root of 4 is 2, so that would give us our points. 0, 0, 1, 1, 4, 2. If you wanted, you could do 9, 3. So there's your parent function, and you could always check that with your calculator, not the wall. Use your calculator. Okay, the minus 2 is going to do what to my graph? Right 2. The 3 is on the outside, so it's a y, so it's a vertical stretch. Okay, so essentially what that's telling me is you're going to take these y values of your original points and you're going to multiply them by 3 to stretch it. So if you're at 0, 0 times 3 is still 0, so that one doesn't move. And then you go right 2. Okay, 1, 1. So my y value is 1. If I multiply that by 3, it goes up to 3. And then right 2. We have 4, 2. Y value is 2. Multiply that by 3, and we get a 6. And then right 2. So your graph looks something like that. Now, I know the stretching and shrinking has been more difficult for you guys. So, strategy, if, let's say, you're not sure what that 3 is going to do. Obviously, your calculator, you can graph it and kind of look and see if your graph looks right. You could also, if you really get stuck, just make a T-chart for this whole thing. Now, if I made that T-chart, we already know I can't put in a 0 because then you get a negative under your radical. So if I started with a 2. Now 2 minus 2 is 0. Square root of 0 is 0. Times 3 is 0. If I put in a 3, then I get square root of 1, which is 1, times 3 is 3. I'm getting those same points we graph for transformations. So if you guys get stuck, use your resources. Graph it on the calculator, make a T-chart, do something to check your answer. Any questions on that one?
Anybody?
No.
They say no.
Okay. All right. Number 8, how many T-charts do I have to make? 3. Okay. So the first one, no matter what, we have to go ahead and start by plugging in negative 4. Because it doesn't have an equal to, that one will be open. And then it said x is less than the negative 4, so I do things smaller than that. So maybe a negative 5 and a negative 6. So then plug them into 2 plus x. So 2 plus negative 4 is negative 2. 2 plus negative 5 is negative 3. 2 plus negative 6 is negative 4. So I'm going to graph those. Negative 4, negative 2 is open. Negative 5, negative 3. Negative 6, negative 4. So I have my starting point, and you need to extend your line. So that's the first piece. Second one. This one gave me a starting and a stopping point. So I have to plug in both of those. So I have to put in a negative 4. It had an equal to, so it'll be closed. I have to put in a 2. It did not have an equal to, so that one's open. And then I'm going to put something in the middle, maybe a 0. So this is asking for the opposite of x. So opposite of negative 4 is 4. Opposite of 0 is 0. Opposite of 2 is negative 2. So graph those. Negative 4, 4. It's closed. 0, 0. 2, negative 2 is open. Because this had a starting and a stopping point, you're not extending it either direction. It's just a line segment there. the last one, we have to do x greater than or equal to 2, so we have to start with a 2. It would be closed because of the equal to, and then you need things bigger than that, so maybe a 3 and a 4. Then plug those in. 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So 2, 6, 3, 9, 4, 12 is going to be off my graph, but we get the idea there. Is that one okay? All right. Our last graph, we have our parent function is x cubed, which is the chair. Plug in some points so you get your minimum of 3 exact points on your parent function. 0 cubed is 0. 1 to the third power is 1. 2 to the third is 8. If you did your negatives, negative 1, negative 1, negative 2, negative 8. So it looks like that. Check yourself on your calculator if you have to. If you have to write out your t-chart, do that. So we get those points. The negative on my x does what?
Reflect across the y.
It's a negative on the outside. So actually on this graph it looks the same whether you flip across the x or the y. But essentially it's going to flip it across the x. If it were written like this, with the negative inside parentheses, then it's applying to the x and that flips it across the y. If it's just a negative out in front of the whole thing, then that flips it across the x. So we flip across the x and then go down 4. So 0, 0, if you flip across the x, doesn't go anywhere. Down 4. 1, 1, flip it across the x, so it goes down to negative 1, and then move it down 4. 2, 8 would come down to 2, negative 8, down 4. These negative points, when you flip them, they move up, and then down 4. So our final graph looks like that. All right. Any questions about graphing or transformations or what to do if you get stuck on a problem?
Somebody say
No.
something.
Okay. Then let's move on. The next piece, this is hopefully where it got a little bit easier for you guys. This is just asking for you to do some algebraic things with functions. So g minus f of x. So all I have to do is find g, so that's 4x plus 4, minus find f, which was 3x squared minus 2. The most common mistake right here, you notice I wrote mine in parentheses because what do you have to do with that negative? Distribute. And then you're just adding like terms. So I have a negative 3x squared, I have a positive 4x, and positive 4 and positive 2 gives me a plus 6. So that's my final answer. It doesn't matter what order you write those terms in. So if you had like 4x plus 6 minus 3x squared, that's fine. You just have to have all of the terms. Number 11, don't confuse this with the composition. The composition will either look like the f composed with g with a little circle in between, or double parentheses. I don't have either of those here. All this one does is f times g. So again, write those in parentheses. F, 3x squared minus 2, times g, 4x plus 4. And how do we multiply those? FOIL. So For the sake of time, I'm just going to kind of do that real quick here. You should get 12x cubed plus 12x squared minus 8x minus 8. And then if you had any like terms, you would combine them, but we don't. Okay, number 12 is f plus g of 0. So since I gave you a number, you're going to plug that into each of them. We have to put a 0 into f, a 0 into g, and then add them. So f of 0, if you did that, 0 squared is 0, times 3 is 0, minus 2 is negative 2. Put a 0 into g, 4 times 0 is 0, plus 4 is 4. So negative 2 plus 4 is 2. 13, f divided by g of negative 2. So if you put a negative 2 into f, 3 times the negative 2 squared minus 2, divided by, and then you're putting a negative 2 into g. Okay, negative 2 squared is 4, times 3 is 12, minus 2 is 10, 4 times negative 2 is negative 8, plus 4 is negative 4, reduce, so you get negative 5 over 2, or you could have negative 2.5. All right. 14. The domain of g over f. So let's just write this for a second. G is 4x plus 4 divided by f, 3x squared minus 2. You can be pretty confident I'm going to put something like this on your test. We spent a lot of time on domain in this chapter. If you have a fraction, what cannot happen?
10 equals 0 in the denominator.
Okay, so let's just work this out. Don't just try to look at it and write down an answer. Work it out. The bottom, the 3x squared minus 2, cannot equal 0. So if I solve this, I add over my 2, divide by 3. How do you get rid of a square?
Square root.
And anytime you add a square root, what else do you need? Plus and minus. So x cannot equal plus and minus the square root of 2/3. If you look at my answer key, I rewrote that. This is like radical 2 over radical 3. So I got the radical off the bottom, multiplied by radical 3 on top and bottom. So that gives you radical 6 over 3. So on my answer key, I said x cannot equal plus and minus radical 6 over 3. Rule of thumb. If it's just one value that x can't equal, I expect interval notation. So if you solve it and you get x cannot equal 1, then I want you to write that as negative infinity to 1, union 1 to infinity. If you solve it and you get more than one value, so let's say you get x cannot equal plus or minus 1, I have told you that you don't have to write the interval notation. I'm letting you leave it in this notation. So on the test, if it's just one value, you must go ahead and give me the interval notation. I'll count off if you don't. If it's more than one value, I won't count off if you just leave it as x cannot equal and list the numbers. Okay, 15. This little circle tells me it's a composition. So this means g of f of x. Okay, so we start on the inside. F of x is 3x squared minus 2. You are plugging that into g, so that means you go to g, and where there was an x, you plug in 3x squared minus 2. So I have 4 times 3x squared minus 2 plus 4. So simplify, if you distribute, you get 12x squared minus 8 plus 4. So final answer, 12x squared minus 4. Let's talk about 16. So if on the test, I will probably break this down a little bit into parts just to kind of help you guys manage your work. So I would probably say part A, find f of x plus h. So that says you go to this function, and where there was an x, you plug in an x plus h. Okay, common mistake right here. Can you just distribute that square? No. It's more than one term, so if I'm going to square that parenthesis, you have to write it twice in FOIL. Okay. So if I FOIL that, I get x squared plus xh and plus xh would be a 2xh. And h times h is h squared. Then if we distribute your 3, you get 3x squared plus 6xh plus 3h squared minus 2. Okay, that would be how I would ask part A, just the f of x plus h. That's going to be your ugliest answer. From here, it should get cleaner every time. So then the second thing I would say is find f of x plus h minus f of x. So f of x plus h is the answer we just got. Minus, what's f of x? Right, it's that original, 3x squared minus 2. Again, I put this in parentheses because I need to distribute that negative. And the really nice thing is things start canceling out here. 3x squared and negative 3x squared drop out. Negative 2 and positive 2 drop out. So we get 6xh plus 3h squared. Then I would ask for the whole thing. F of x plus h minus f of x all over h. F of x plus h minus f of x, that's what we just did in part B. So we got 6xh plus 3h squared over h. And then what can happen here? Yeah, we can cancel an h out of everything. So if I drop one of those h's out of everything, you're left with 6x plus 3h. And that's your final answer. So these problems, they look really scary and ugly, but if you break it into pieces, you guys can handle it. You can evaluate functions, you can plug things in, you can subtract. So just take it step by step and you'll be okay. Any questions there? I know we're kind of getting short on time, so I'm going to skip around just a bit. I do want to talk about 17 here. Part A, that's asking for the domain of f. If you have a fraction, what's the rule? So x minus 5 cannot equal 0. So x cannot equal 5. Since it's just one value x cannot be, I do want interval notation. Negative infinity to 5, union 5 to infinity. Everything except 5. Okay, B, the domain of G. Alright, so If I'm looking at G is a radical. If you have a square root, what do you know about the thing under the radical?
It can't be negative.
Has to be greater than or equal to 0. So those are the two domain rules you need to know. If it's a fraction, the bottom can't be 0. If it's a radical, the thing underneath is greater than or equal to 0. So if I subtract over my 6, x is greater than or equal to negative 6. So equal to means bracket. You want everything bigger than that. The negative 6 to infinity. C and D are really asking the same question, so I'll just do one of them. D, f composed with g of negative 2. So you start on the inside. If I plug a negative 2 into g, that gives me the square root of 4, which is 2. So then we have f of 2. So you go to f, and if you plug in a 2, you get negative 2 over negative 7, or just a positive 2 over 7. It's just asking us to plug in. Number 18, are you guys okay with that? You would just plug in a negative 5 for your x and simplify? Okay. Let's talk about 19. So G composed with F. So that's wanting G of F is 3 over x. So we go to G, we replace our x with the 3 over x. Now shortcut here, you can't leave a fraction in a fraction. So if I look, this little fraction has an x on the bottom. All I'm going to do is take the top and bottom of this fraction and multiply it by x. So on the top, 5 times x is 5x. On the bottom, 3 over x times x is a 3, minus 1 times x is x. So there's my composition. When I ask for the domain of a composition, you have to look 2 places. You look at the original and your final answer. If I'm looking at my original, it's a fraction, so x cannot be 0. If I'm looking at the final, it's a fraction, so x can't be
Louder. Can't be 3.
3. So put those together, x cannot be 0 or 3. And since it's more than one value, you can just leave it as that. Okay. What I would like to do to finish is skip down and maybe look at like 23, 25, and 27, just so we've hit one of each of those. And then we should have talked about all the different types. 23, if you have an absolute value equation, how do you solve those? 2 equations. The first one, all you do is drop the absolute values. The second one, you drop the absolute value and you make one side negative. You notice I put my negative outside and then I put parentheses because I'd have to distribute that. From here, can you guys solve these equations? Do I need to show the work for solving it? Okay, so you would just solve both of those. On 25, what you need to remember, if it's a greater than, is that an and or an or statement? Greater than is or. So you make 2. The first one, you drop your absolute value, and nothing else changes. Second one, you have to flip the inequality and make it a negative. So it's either greater than 2 or less than negative 2. If you solve these, make sure in that, so you'd subtract your 7. If you divide by a negative, what happens? Right, flips your sign. On those, because they are inequalities, I would expect interval notation. So less than or equal to 5/3 would be negative infinity to 5/3 equal to, so it gets a bracket. Union greater than or equal to 3 would start at 3 and go to infinity. If it's an or, you should get two intervals at the bottom. Okay, and really quickly, this last one, before I do anything, you have to isolate the absolute value. So first thing, I have to divide by my -2, and that dividing by a negative flips my inequality. So now it's a less than. Less than means and. So I'm going to have one big inequality. Put it in between the negative and the positive. Both of your inequality symbols going the same way. So then if you add 4 to all pieces, you get 1 is less than x is less than 7. So you just get a single interval for your answer. Okay, I know that I kind of went fast here at the end and I didn't hit everything. If you guys are studying and you have any questions, shoot me an email. I will answer those. I'll check my email. Okay, otherwise, thanks and good luck on your test.
Thank you.
You're welcome.